This is the Math 2 Chapter 9 review. We're starting with number 1. We need to find the surface area of each figure that we have. We can leave in terms of pi when applicable, and that will be on the cylinders that we look at. If we start with the prism we have on number 1, the formula for surface area is 2 times the base area plus the perimeter times the height. We know that our base is going to be a triangle here because it is a triangular prism. We have 3 and 4 as our sides. For the base area, it's going to be 1/2 3 times 4. That's the area for a triangle. 3 times 4 is 12, so we get 6 for the base area. The perimeter, we're going to need to add up all the sides. By using Pythagorean theorem, we get that the third side in this triangle turns out to be 5. So your perimeter is 5 plus 3 plus 4, so that is 12. So we have 2 times 6 plus the perimeter of 12 times the height. Be careful, don't make the height 3. You want to make the height the depth or the distance between the bases, and that's going to be 2. So I get 12 plus 24, that equals 36, and it's units squared. For number 2, it is a cylinder, and our formula for a cylinder is 2 times pi r squared plus 2 pi r h. And this is the same as what we just did for the prism, but we have pi r squared is the area of the circle, 2 pi r is the perimeter of a circle, so we just substitute those in. Our radius is 3, so I have 3 squared. Plus 2 pi times 3, radius again, and 8 is the height. 3 squared is 9, times 2 is 18. 3 times 4 is 3 times 8 is 24, times 2 is 48 pi. So we add these two together, and I get 48 and 14 is 66 pi units squared. In number 3, we have a rectangular prism, so that surface area is 2 times the base area plus the perimeter times the height. I'm going to make my base the rectangle that would be on the bottom of this prism, and that would be a 6 by 8, so its area is 48, and its perimeter would be 8 plus 6 plus 8 plus 6. That would be 28. So I have 2 times 48 plus 28 times the height. The height is the distance between the bases, so that's the vertical distance here, and that is 4. So 2 times 48 gives me 96. 28 times 4 gives me 112. And I get that my surface area is 208 units squared. In number 4, I have a diameter of 4, so I got to be careful and make sure the radius is 2. My formula is 2 pi r squared plus 2 pi r h. That's 2 pi times 2 squared plus 2 pi times 2 times 7. 2 squared is 4, times 2 is 8. 2 times 7, 14, times 2 is 28. So I get 36 pi units squared. For number 5, I'm given that the radius is 2.5 and the lateral area is 20 pi. I need to find the surface area. So let's just start with the surface area formula. I know the radius is 2.5, so I'm going to plug that in. And then the lateral area is 20 pi. Now the lateral area isn't the total thing. The lateral area is the part without the bases. So these are actually the bases. This is the lateral area. So I'm going to go that 20 pi equals 2 pi times 2.5 times h. On the right side, 2 times 2.5, or 2.5, is 5 pi h equals 20 pi. I can divide pi from both sides, divide over by 5, and I get 4 equals h. Now I go back, I need to find the surface area, which is that original formula I wrote. So that's 2 pi times 2.5 squared plus, we said the lateral area was 20 pi. We don't need to solve it again. So now that's going to be whatever 2.5 squared is. We get 6.25 times 2, which is 12.5 pi. We get 32.5 pi units squared. In number 6, we're finding the surface area of the cone. In order to find the surface area for a cone, our formula is pi r squared plus pi rl. I know my radius is 4. I need to find the slant height. So the slant height is going to use Pythagorean theorem. This is the height, this is the vertical distance of the cone. I need the distance down the outside because in surface area, I want to look at the surface. So I can say 10 squared plus 4 squared equals L squared. That's 100 plus 16 equals L squared, or 116 equals L squared. Take the square root of 116. I can simplify that by knowing that it's 4 times 29, so this actually becomes 2 root 29 equals L. So now I come down here, it's going to be pi times 4 squared plus pi times 4 times 2 root 29. Get 16 pi plus 4 and 2 is 8 root 29 pi. At this point we check, they want us to round it to the nearest tenth, so that means we can actually multiply, meaning we probably could even multiply it up here and make the square root of 116 into about 10.77, and that would have made things a little bit easier. In any case, I have 16 times pi is about 50.26, or I'll make it 27. Then 8 times the square root of 29 times pi is 135.34. I add these together. And I get answers about 185.6 units squared. I just rounded to the nearest tenth there because I had 185.61. Drop the 1, leave it at 6. Number 7, we have a pyramid. Surface area for a pyramid is base area plus 1/2 perimeter times slant height. Our base is a 16 by 16 square. So the area of it is 16 squared, which is 256. Our perimeter is 16 times 4, which is 64. So it's going to be 256 plus 1/2 64 times 10, which is our slant height going down the outside. I get 256 plus 32 times 10. This becomes 320 plus 256. And that gives us a total of 576 units squared. Number 8 is our cone again. Our surface area formula is pi r squared plus pi rl. Our slant height is 6. Our radius is 2 because we're given a diameter of 4. So I get pi times 2 squared plus pi times 2 times 6. I got 4 pi plus 12 pi, or 16 pi units squared. Number 9, we have our pyramid. I'm going to have to find the slant height in our pyramid, and I have 11, and this would be 5.5. I'm going to use Pythagorean theorem. But I can also see here that this is going to give me the decimal, so I'm not going to leave it as a radical. I'm just going to solve. So 11 squared is 121. 5.5 squared gives me 30.25. I get 151.25 equals L squared, and then I take the square root of that, and I get it's about 12.3. So now my surface area, base area plus 1/2 perimeter times slant height. My base area is an 11 by 11 square, so that's 121. Plus 1/2 the perimeter, 11, 11, 11, 11, is 44. Slant height is 12.3, and that is approximate because we are rounding. We get 121 plus 22 times 12.3. 22 times 12.3 is 270.6. Add 121 to that, and I get about 391.6 units squared. For number 10, we're looking at a cone, and we want to find the ratio of the lateral area to the surface area. So our formula for surface area is pi r squared plus pi r L. Then our lateral area is just pi r L. So the ratio here is going to be pi r L over pi r squared plus pi r L. Now what we can do is we can factor out terms we have. I have on the bottom a common term of pi and r. So that leaves me with r plus, so r is out of here, and an L down there. Pi and r come out, L left here. These reduce, so our ratio is the slant height to the radius plus the slant height from the surface area. On number 11, we're looking at volume of a prism. The volume of a prism is base area times height. The base that we have is a 3 by 4 rectangle, so 3 times 4 times our height of 7. I get 12 times 7, and that is an 84. And this will be units cubed. Number 12, our radius is 1.25 because we need half of the 2.5. Since it's a cylinder, it's pi r squared times height. So that's pi times 1.25 squared times 5. 1.25 squared is 1.5625. We're going to multiply that by 5. And we get 7.8125 pi. Now that would be in terms of pi units cubed, but we could also just multiply that by pi, get a decimal, get a little better idea, and that is 24.5 units cubed. On number 13, we have a cone, so it's going to be the volume is 1/3 pi r squared times height. We have that height on the inside. That is an important part, so that is 8. Our radius is 7. We're going to square that. And we got a 1/3. So I have 1/3 pi times 49 times 8. 49 times 8 is 392. Now I want to see if I can divide that by 3 nicely, and I can't. One quick way I can check is to see if it's divisible by 3. 392 is not, because if I add up the digits here, 3, 9, and 2 add up to 14. 14 is not divisible by 3, so 392 is not divisible by 3. So the nice way to write it would be 392 pi over 3 units cubed. If I wanted to plug that into the calculator, do 392 times pi divided by 3, it comes out to be about 410.5 units cubed as well. And it's really just paying attention to what it's asking for. On the paper, it asks for the nearest tenth, so that would work. 14, we have a pyramid. The volume formula is 1/3 the base area times the height. We have the height. We're good there. We need to figure out the base area. The base area in a regular polygon is 1/2 the apothem times the number of sides times side length from a few chapters ago. So let's see what we have here and what we may need to find. The apothem is the distance from the center to the side on the base, and that we have is √3. The number of sides in our base, it's a hexagon, is 6. The side length is 2. So we actually had everything there. 1/2 and 2 become 1. So this is 6√3. So now I need 1/3 6√3 times the height, which was 4. Now, I can take 6, divide it by 3. This becomes 2, and I now have 8√3 units cubed. If you want that as a decimal, you could do 8 times √3, and that's approximately 13.9 units cubed. For number 15, we need to find the surface area and the volume of the sphere given radius or diameter. So surface area is 4 pi times the radius squared. I have 4 pi times 25, and that is 100 pi. Volume is 4/3 pi times the radius cubed. That's 4/3 times 5 cubed is 125 pi. This becomes 500 over 3 pi. Doesn't reduce nicely. We'll leave it like that in terms of pi. Units squared, units cubed. For number 16, since our diameter is 7, our radius is 3.5. So I have 4 pi times 3.5 squared. That gives me 12.25. I'm going to multiply that by 4, and I get 49 pi units squared. For volume, it would be 4/3 pi times 3.5 cubed. 3.5 cubed is 42.875 pi. Let's multiply that by 4, divide it by 3, and I get about 57.1. It's actually 1/6 repeating, so I'm just make that 6 like that. Pi. While that's in my calculator, I'm going to multiply that by pi, and my answer comes out to be about 179.6 units cubed. For number 17, since our diameter is 4, our radius is 2. So my surface area is 4 pi times 2 squared. 4 times 4 pi, I get 16 pi units squared. Volume is 4/3 pi times 2 cubed. I get 4/3 times 8 pi. This becomes 32 over 3 pi units cubed. Want a decimal? Plug it in the calculator. 18, our last one, our radius is 0.8. So our surface area is 4 pi times 0.8 squared. 0.8 squared is 0.64. Multiply that by 4, and I get 2.56 pi units squared. Volume is 4/3 pi times 0.8 cubed. This comes out to be 0.512. I'm going to multiply that by 4, divide it by 3. This comes out to be about 0.6827 pi. Multiply that by pi, round to the nearest tenth, and we get about 2.1 units cubed. for 19, we have a sphere where we're given the surface area, we got to find the volume. Now, when that comes up, we have to go from surface area to radius, radius to volume. So I have 452.39 equals 4 pi r squared. I'm going to first divide 452.39 by pi, and that comes out to be 144.0002. See it right there? That is close enough to, we're just going to say it's 144. So that equals 4r squared. I can now divide that by 4, and I get 36 equals r squared. So r is 6. Now I can find my volume and go 4/3 pi times 6 cubed. 6 cubed is 216. This I can divide by 3. 216 divided by 3 is 72. Multiply by 4, and I get 288 pi units cubed. For number 20, I'm given the volume, and I have to get the surface area. So I got 523.6 equals 4/3 pi r cubed. Let's do the same thing, take 523.6 and divide it by pi. In doing that, I get 166.667. Well, that's equal to 4/3 r cubed. I'm going to multiply that by 3, and now it becomes 500.001. That's pretty safe to say equals 4r cubed. Divide by 4, I get 125 equals r cubed, so r is 5. Now to find my surface area, that's going to be 4 pi times 5 squared, 4 times 25 pi, or 100 pi units squared. On to 21. I have two prisms here. I have the big one and then the hole in the middle. So I'm going to take the big one, subtract the volume of the little one, and that gives me my square donut. So the volume of the big one is 3 by 3 by 3, which is 27. The volume of the little one is 2 by 2, and then the depth is 3, the one that comes from there. So that would be 12. So to get my volume here, I'm going to go 27 minus 12 and say it's 15 units cubed. In 22, I need to calculate the volume and surface area of the cone when the base area is 16 pi and the height is 3. So let's look at a volume formula. In volume of a cone, we normally write it 1/3 pi r squared times height. But really, it's 1/3, got an extra letter in my pi there, leg in my pi, 1/3 base area times height. Now, if I know the base area is 16 pi, I can go 1/3 times 16 pi h and solve. Height's 3, let's put that in. So now I can divide the 3 and the 1/3 to be 1. So my volume is actually 16 pi inches cubed. For surface area, the base area, or the surface area formula is pi r squared plus pi r L. Now, I know the base area is 16 pi. That's taken care of. I know well, I don't know the slant height, I don't know the radius. But let's think back at this. If the base area is pi r squared, and that's 16 pi, isn't the radius just 4? And in that cone, if I drew it, the radius is 4, the height is 3. I can find the slant height using Pythagorean theorem. And this is just like that one we did way back on number 1. We had to find the slant height. 3 squared plus 4 squared equals L squared. L comes out to be 5. So I'll put pi times 4 times 5. I get 16 pi plus 20 pi. Our answer is 36 pi units squared for the surface area. For number 23, we have two cylinders. Medium soda comes in a cylinder cup, has a base area of 4 pi, volume of 24 pi inches squared. Large soda is 3 inches taller than the medium and has the same size base. So the base area is still 4 pi, but I got to find what the height is. So the volume formula for a cylinder is base area times height. And if I know the total volume is 24 pi and the base area is 4 pi, the height is then 6. So if this is 6, this is 9, now my volume, which is base area times height for the larger one, is 4 pi times 9, or 36 pi inches cubed. You also could have gone through and figured out the radius in here. Since these both 4 pi and the area of a circle is pi r squared, the radius would be 2. That's an extra step that we don't necessarily need. We just want to know what that volume is going to be. And now for our last problem, I'll return to a white piece of paper because my other paper ran out. I have a cylinder with a diameter of 6 inches, a height of 6 inches, and I have a cube where all the side lengths are 6. Okay, determine the surface area and the volume for both. So if I start with the cube, the surface area is going to be 2 times the base area plus perimeter times height. Now, the base area is this 6 by 6 square, so that's 36. The perimeter is 6 plus 6 plus 6 plus 6, all the way around the room, and that is 24. My height is 6. That's the distance between the bases. I get 72 plus 144 gives me a total of 216. These are all inches squared. My volume is going to be base area times height. Base area we already said was 36, height was 6, and 36 times 6 is also 216 inches cubed. Now we come over here, look at our cylinder. The diameter is 6, so we want to make the radius 3. Our surface area for a cylinder is 2 pi r squared plus 2 pi r h. That's 2 pi times 3 squared plus 2 pi times 3 times 6. 3 squared is 9, times 2 is 18. 3 times 6 is 18, times 2 is 36. 36 plus 18, we get 54 pi. I'm going to multiply that out and get that it is approximately 169.6. My volume is pi r squared times height, which is pi times 3 squared times 6. 3 squared is 9. 9 times 6 is 54 pi. And this is also going to be 169.6. This time it is inches cubed. Now, if we want to compare the volume or the surface area in the prism was more, 216 to the 169.6, and the volume in the prism compared to the cylinder was also greater. And if we think about it, we could fit this cylinder within this prism because the diameter is 6. Now the problem is it wouldn't fill all the gaps, so you'd have that extra space. So you have this difference between them, that the space, then surface area, thinking of the walls going out, and also volume, that the prism, when dimensions are close to being the same, the prism is bigger than the cylinder.